So here's a problem for us. A skater is moving at 12 meters per second and accelerates at 2.3 meters per second squared for 0.62 seconds. What we want to know is how fast is the skater now moving? It's provided. We have a velocity or a speed, and we'll call that the initial velocity of 12 meters per second. We also have an acceleration of 2.3 meters per second squared, and we have a time of 0.62 seconds. Now, what this time actually represents is it's technically a change in time, which is a final time subtract an initial time. Time is 0 seconds. And so our delta t is basically our final time subtract 0. So our delta t and our t are essentially the same thing when the initial time equals 0. In a previous video, we learned that acceleration is a change in velocity over time, or essentially it's the final time subtract the initial time, but in this case, the initial time was 0. What we want to do is we want to find the final velocity. So we're going to have to do a little bit of algebra with our equation to solve this. So what I'm going to do is I'm going to remove the t from the bottom of this equation. I'm going to end up with at equals the change in velocity. And we have to remember that the change in velocity is the final velocity subtract the initial velocity. So AT equals VF subtract VI. So if I want to know the final velocity, a little bit more algebra, I'll have VI plus AT. And we can use this equation right here to solve our problem. The final velocity, and that equals the initial velocity plus the acceleration multiplied by time. We want to be very cautious of our units, so I'll be sure to include them. Our initial velocity was 12 meters per second, and to that we're going to add our acceleration, which was 2.3 meters per second squared, multiplied by our time of 0.62 seconds. So our final velocity will be 12 meters per second plus, and when I take my 2.3 multiplied by 0.62, I'm going to end up with an answer of 1.4. And if I watch my units, I'll see that the seconds on the bottom here will cancel with the seconds on the top there. And I'll end up with a units of meters per second. So now I can simply add my units together. 12 plus 1.4 to the proper number of digits will give me 13 meters per second. That's how fast the skater is now traveling. Equal to the initial velocity plus AT is a very common calculation that we do, and we do it frequently in physics. So we're going to refer to this as our second kinematics equation. And of course, it can be maneuvered around and a little bit of algebra to solve for the other variables. But the secret here is that we use this when we don't know our distance or displacement. Now, I'm not going to go through all the algebra steps here, but if I want to solve for VI would be equal to VF subtract AT. With a little more algebra, we can also use this equation to find time. Time is equal to the final velocity, subtract the initial velocity, and divide your total by acceleration. And don't forget our original equation, which was our final velocity subtract our initial velocity divided by time.